Hola. Okay, so I am doing my physics video on black holes, and this is my.
No, I'm introducing myself.
Okay,
I,
fine.
I'm my brother. I'm Joseph Burnett, like the brother of this vegan hippie with no friends.
I
Alright, let's
have
go. You don't have
friends.
no friends.
I have friends.
You have no friends. Let's go.
I have friends.
Oh yeah. What exactly is a black hole?
So a black hole is a place in the universe where a lot of mass has been squeezed into a very tight space, making the force of gravity so strong that not even light can escape. Because
Eye contact with you.
black holes. Because light can't escape from a black hole, people can't see black holes. Black holes are incredibly massive, but only cover a small region of space. Because of the relationship between mass and gravity, this means that they have an extremely powerful gravitational force.
Off script here. Does that have anything to do with density?
It kind of does because the mass that has once inhabited a large amount of space has been squeezed into such a tiny amount of space, it makes black holes very dense.
So the stars that explode into a supernova don't lose any of their density. They don't lose any of their mass. They don't lose any of their mass. They just get compressed and keep their mass just increase with it.
Yes.
Good to know. How are black holes created?
Most of the black holes in the universe are formed after a star uses up all of its fuel and blows off its exterior in a gigantic explosion. In
AKA,
other words,
I steal all its fire from my mixtape.
a supernova.
Right?
When the mass of a star is within its Schwarzschild radius, the gravity of... Yes, it's German, we know. The gravity of what's left of the star forces the star to collapse under its own weight. The amount of mass in such a dense space doesn't let anything escape it, not even light, meaning it is now a black hole. Not anything can become a black hole. Our sun and Earth simply aren't massive enough to become black holes. Stars generally have to be a lot more massive than our sun to become one.
Wait, what is this Schwarzschild radius thing? I don't get it.
It's when the radius of a sphere... It's the radius of a sphere when all the mass of a certain object is compressed within that sphere. The escape velocity from the surface of the sphere would equal the speed of light. Now that's like what Google says the definition is, but basically when an object such as a star collapses, all the mass that the star has is compressed into a very small space, making a black hole and causing there to be a point of no return, or an event horizon around that black hole. Once an object or light crosses this point of a black hole, escape is impossible.
What's at the center of a black hole?
At the center of a black hole is what physicists call singularity, or a point where extremely large amounts of matter are crushed into an infinitely small amount of space.
Hold it. I just want to know here. Is this pretty much all theory, or has anyone sent a camera into a black hole? How do we know all this?
I will get to that later, actually. Okay, so I was talking about singularity. Around the singularity, any particles and materials that have gone inside the black hole are compressed. As matter collapses into a black hole, it becomes very dense because the mass that the object has to fit into a very small amount of space.
So what would happen to me if I ever had the chance to fall into a black hole?
Okay, well, first of all, let me tell you, you wouldn't want to.
Okay.
If you were falling toward a black hole, most of the time you would simply feel weightless. The gravity of a black hole is just like the gravity of any other large mass as long as you don't get too close. If you were falling feet first toward a black hole, your feet would feel a stronger force in your head. These differences in forces are called tidal forces. Because of the tidal forces, it would feel as if you were being stretched head to toe, while your sides would feel like they were being pushed inward. Eventually, the tidal forces would become so strong that they would rip you apart. It's certainly not your ideal vacation spot.
So you would be spaghettified and just torn apart.
Yes,
How do we know black holes exist?
Okay, so we can't see a black hole itself, since not even light can escape the hole's gravitational field, but we can see the hole's effects on nearby matter. For example, if gas from a nearby star were sucked towards the black hole, the intense gravitational energy would heat the gas to millions of degrees. The resulting X-ray emissions would point to the presence of a black hole. Or, if a massive black hole were surrounded by large amounts of orbiting material, such as gas, dust, or stars, their rapid motion close to the hole could be observable via shifts in the energy of the radiation they emit. Evidence along these lines is mounting, suggesting that black holes may not be that rare in the universe. Such evidence remains indirect and therefore inconclusive. To confirm that black holes actually exist, we'll need to be able to observe the gravitational waves they produce as they form or interact. However, astronomers have found convincing evidence for a supermassive black hole in the center of our own Milky Way galaxy, the galaxy NGC 4258, the giant elliptical galaxy M87, and several. Scientists verified the existence of the black holes by studying the speeds of the clouds of gas orbiting these regions. In 1994, the Hubble Space Telescope data measured the mass of an unseen object at the center of galaxy M87. Based on the motion of the material whirling around the center, the object is estimated to be about 3 billion times the mass of our Sun and appears to be concentrated into a space smaller than our solar system. For many years, X-ray emissions from the double star system Cygnus X1 convinced many astronomers that the system can cool. With more precise measurements available recently, the evidence for a black hole in Cygnus X1 and about a dozen others is very strong.
Who came up with the idea of black holes?
How black holes are created and how they work have essentially been studied for many centuries, with many people developing our understanding of them. And this is going to be a long list here, but bear with me. And so in 1687, Isaac Newton described gravity in his publication Principia. In 1783, John Michell believed that there might be an object massive enough to have an escape velocity greater than the speed of light. So in 1796, Simon Pierre Laplace predicted the existence of black holes. In 1915, Albert Einstein published the theory of general relativity, which predicted space-time curvature. In 1916, Carl Schwarzschild used Einstein's theory of general relativity to find a black hole. He defined the gravitational radius of black holes, which was later called the Schwarzschild radius. In 1964, John Wheeler coined the term black hole. In 1970, Stephen Hawking defined the modern theory of black holes and has done multiple studies on black holes and their behavior.
What are some popular myths about black holes?
Okay, so one is that black holes are giant cosmic vacuum cleaners that swallow up everything around them. That is not true. Black holes do not suck up nearby material. If the sun were magically converted into a black hole, which cannot happen by the way, Earth's orbit would not change.
I mean, we know so little about black holes, it probably could happen.
Well,
might be wrong.
No, because as far as we know, our sun is not massive enough.
And we know very little.
Yes, we actually do know very little. So if the sun were magically converted into a black hole, Earth's orbit would not change. Material generally falls into a black hole when it collides with other material orbiting the black hole. The collision alters the material's orbit. Instead of orbiting a comfortable distance from the black hole, the material is now orbiting too close to the black hole. Then the black hole's enormous gravity traps the material in a one-way spiral to oblivion. Another is that we can actually see black holes. The light produced or reflected by objects is what makes them visible. Since no light can escape from a black hole, we can't see it. Instead, we observe black holes indirectly by their effects on material. So, the third myth is that black holes can lead to other places. In science fiction, TV shows and movies, and probably books as well, people sometimes travel through wormholes. Many students think black holes are wormholes and therefore lead to other places. Wormholes are an intriguing possibility, but have not been shown to exist. Also, any object entering a black hole gets crushed. You would die before you traveled to another galaxy through the black hole. Through a black hole.
And we're done. Yes, I've got to find a black hole if we're going to throw you into it.
No.
Like, I would watch. Like I would hold. I would just no. I would
No.
literally like tie you to a rope and throw you in there, and then I would just slowly cut the rope. That's what I would do. Me the whole time you're just screaming that your feet are being spaghettified, and I would just be like,
Somebody call the police.